And hi everyone, welcome to Life Edge, because life just doesn't have to be mediocre. And I've got somebody who's not mediocre at all right next to me here, and her name, Dr. Susan Nash. Hey Susan, how are you?
Good. Great to be here, and we have a great guest, Sunil Garg of DataVedic, who will talk to us about machine learning and deep learning and all we want to know about artificial intelligence.
Fascinating topic. Here we go. And joining us from the center position of power, as we like to call it, we've got Sunil Garg with us. Susan, would you like to introduce Sunil?
Yes, I've known Sunil for a couple of years now, and he's the founder and CEO of DataVedic, and that's an analytics company that does a number of things. A lot of it's based around artificial intelligence, but maybe, Sunil, you can tell us how DataVedic got started.
Sure, Susan. So first, thanks a lot for inviting me to the show. It feels great to talk to you live here. Right. So like Susan said, we have known each other for about a couple of years. So to give you some background on how DataVedic started, we started the company about May of last year. So May of 2017 is when DataVedic got born. The idea had been germinating for some time before we started it formally. And the primary reason we started DataVedic was to get more value out of data, right? So that's, for ourselves, for our customers, for the world in general, right? We want to make a difference in the lives of the people. We want to make a difference in whatever is happening around the world, right? So we want to touch the lives of the people. And we saw data analytics and machine learning as a great way of doing that. From my background, is software development in oil and gas. So, and I used to run the data analytics and machine learning division for Schlumberger, which is one of the biggest oil field services company in the world. Right. So before I started DataVedic, in fact, I was kind of doing similar work at Schlumberger, but that was, of course, working for a large corporation versus DataVedic, which is more of a startup.
That's interesting.
Yes. Well, a quick question. So in terms of analytics and the types of machine learning that you were doing at the beginning, what was it like when you first were working at Schlumberger, and how has it changed?
So that's a very interesting question, in fact, Susan, because that kind of reflects on, one, the evolution of data analytics in general, and also specific to oil and gas industry. So as everybody knows, oil and gas industry in general is not at the forefront of technology leadership. Right? They have adopted a lot of new technology, but it's generally not the first thing that they would adopt when a new technology comes in. So I started the business at Schlumberger around 2014. This was, you can say, about Q3 of 2014. And at that time, the oil and gas prices were still very high. So my observation in general was, as I was gauging the market for data analytics and machine learning, there was interest, but there wasn't a huge response to what we were trying to do. All that changed very rapidly in 2015. As we neared, you can say, the end of first quarter of 2015, the oil prices really slid, right? So they really came down to half, basically, in the matter of 6 months. And that's when suddenly the interest in data analytics started growing in the oil and gas industry. That's when a lot of the clients started expressing interest in what we were trying to do. Right? So that's kind of something which was very specific to oil and gas industry, simply because the economy, oil and gas economy went down. So everybody was looking at, how can I cut the costs? How can I improve my people's efficiencies? How can I prevent the safety incidents? How can I reduce the non-productive time? And they felt like data analytics and machine learning could provide some answers, and as a technology could help them achieve that. So that, you can say, was the beginning of life around 2015 in data analytics for oil and gas. The way it has evolved, you can think of that every large oil and gas corporation today is involved in some kind of digital transformation initiative which revolves and is built around data analytics. In 2014, you would probably find only some industry leaders doing it. Schlumberger was, in fact, the forefront of it. We started digital transformation initiative way back, I would say, around 2011. Right? So that has been a big change in oil and gas industry. You also see a lot of adoption of the solutions that are being developed, and people really using that in practical life. Essentially optimizing their operations using data analytics and machine learning today. And I see that we have still not reached the peak as far as I can see in oil and gas industry. I think that peak is yet to come in terms of the AI, machine learning, data analytics, robotics, all of that. I think the usage will keep rising.
Now, we talked a little bit pre-show about the machine learning side of it and how you create the heuristics or the algorithms to enable the machines to understand what they're doing, to understand cause and effect of what happens. How is that used to improve the performance, let's say, in the industry? Let's say we're looking at the petroleum industry. How does machine learning, including with the data analytics that you're capturing, improve the performance overall of the company or of that specific sector?
Sure. Yeah, happy to share that, in fact. So oil and gas industry is kind of unique in the fact that there are a lot of operations, one, which are very expensive, second, which have a lot of uncertainty, and third, which have a lot of potential of incidents which result in non-productive time, and including some safety incidents which can impact human life. Right? So all of these areas are great areas, I would say, for AI, because oil and gas generates a lot of data during the operations, and in general in oil and gas, the management of this data and the focus on deriving value from this data was kind of focused on applying well-known physics around. Yep. And a lot of the data that was being generated was not even being used for anything. It was being archived, maybe it was being saved by the people, and a lot of the times it was thrown away because, one, the technology for storage was not great, it was expensive. So in terms of money going in, it was pretty much an investment, or in some cases it was treated pretty much as an expense, right, due to the lack of value that could come out of it. So all of these places where I would say uncertainty is high, oil and gas industry is now using machine learning effectively to reduce that uncertainty. It is also using machine learning to, for example, optimize the operations. A lot of the resources being used, including equipment, the facilities, the people. So it's using that to kind of optimize the operations. And in a typical downturn environment, which we see in oil and gas for last 4 years, most companies, in fact, have cut down on the manpower. So a lot of the people have retired, and a lot of the people have been let go by the companies, which means that everybody is short on people right now. Right? So operational efficiency, the improvement of the operational efficiency is the focus of every company. It's essentially saying, can I use technology to improve the efficiency of my people so that every person can do a little bit more than what they could do in the past. Right? So that is a lot of focus in the oil and gas industry. Similarly, I would say any place where they can generate more revenue and ultimately make more reliable and faster decisions, right? Which ultimately impacts everything, including the generation of revenue, including cost optimization, including human efficiency, right? They're utilizing that data.
Now, you mentioned that they've been capturing that data for a very long time. Do people still have the data? Did they save it? Can you go back and actually analyze some of that data?
That is true, actually. In some cases, yes. For example, the exploration data, right? The typical data that is gathered using, for example, seismic surveys, in order to gauge, when you are in the very beginning of gauging whether a particular area has oil or not, that data was typically archived and it was interpreted as well. But the new techniques that have come in, the new technologies that have come in, as well as the speed and scale at which you can do the things today, is making the oil and gas companies relook at this data and say, can I derive more value out of this data from which I have derived some value already in the past, but maybe the technology was not there to give me the entire value. That has been one place. Another place where they are using or utilizing a lot of the old data is also where a lot of high frequency data was coming. Right? So in some cases, people are not sure what to use that data for, and they store that data. Right? And now there are great uses of some of this data. I also know of companies which acquire the data for some time and then realize that the cost of storing the data became huge compared to the value that they were deriving out of it, and threw it away. But they are coming back and saying, well, I don't want to throw it away anymore. Maybe I will discover some value now, maybe I will discover a huge value in the future, but let me at least archive that data.
What's interesting,
to do that first.
That's really fascinating, because sometimes when you look at old data, one of the things that comes out are micro trends, the really small trends that just might be small little deviations from the norm, but all of a sudden those small deviations taken into a big account can make a big difference in the result of what they're analyzing. They say, we've had little small trends that cost more or created issues or more incidents, but they're small. But then you take them as a whole, you can look at the amount of effort, money, lives, everything that was affected by that small little deviation that maybe they didn't account for before, and all of a sudden, this is interesting. Now, I find it really fascinating how you take the data, whether it's current or older data, and you can massage it in so many ways now, which we couldn't before. The computers are so much faster. In fact, I was reading an article today that said software has not gotten any faster in the last 40 years, but computers have sped up about 1,000%. And it's sort of interesting. Our software skills aren't programming any better, but the computers, the chips are so fast, and they can do so many multiple cores and processes that it's amazing what we can get out of them now. So it's just sort of fascinating. Susan?
Well, so one thing I wanted to mention is that Sunil and DataVedic helped last summer in what we had called a hackathon, where we hacked Python code to come up with, and then we had teams, and they came up with the best codes for predicting fluid flow in a well. And it was so much fun. Yeah, and so Sunil was a judge, but then some people from DataVedic were part of the coaches and helping with the Python. And one of the big challenges was the data integrity. So what do you do, Sunil, whenever you come up with a situation where the data is like kind of, you don't know about it?
Yeah, in fact, data integrity is a big issue in general, anywhere where the data is generated. And that's not, in fact, oil and gas industry has a lot of this messy data as well, but I've seen it in other places. If you look at meteorological data, if you look at the storms data, we have a storms database in the country, and if you look at all of that storm data, you will be amazed to find, what kind of data is stored there. Units are wrong sometimes. You can't really know sometimes the numbers. When the number is mentioned there, let's say the number says, well, 100 people got impacted. You don't really know whether that was 100 million or whether it was 100,000, that was 10,000, because the unit is completely missing, right? And that happens a lot, in fact, all over the place in the data. And that makes, in fact, life very difficult to use that data for any effective purposes. On the oil and gas side, I would say a lot of uncertainty comes from that, because in a typical operation, there are generally many companies involved, each with their, let's say, equipment, each with their own calibrations. So lots of the times, the data is not calibrated correctly or in a unified manner. So when you try to make some sense out of the data which different companies are collecting, especially in the drilling area, right, that's a very typical problem. On a drilling rig, many companies are present, and their clocks are typically not synchronized between the various equipments and the sensors they are using. Right, to make some sense out of the data, you have to do some kind of messaging. In fact, this is one of the areas, when Susan mentioned it, right, this is one of the areas where DataVedic specializes in, because it kind of focused on improving the quality of the data as we were trying to derive the value of the data. And one of the reasons we focused on that was the company that got formed as DataVedic, right? The people, half of the you can say manpower came from the team that we had at Schlumberger, and I used to run the Schlumberger's data management business at one point of time. And data management was all about gathering data, preserving data, improving the quality of the data, making sure that reliable data can be made available to people whenever they need it. Right, so we were already grounded in the data quality aspect of the data. So that's one of the reasons why we always think of how we can improve the data quality before we do anything.
That's
And by the way,
fascinating.
Rick, you made a very interesting comment earlier about the fact that the computers have become faster, but my observation has been very similar to what you said, which is the programming has not necessarily become much
No.
better. In fact,
No.
we see a lot of careless programming nowadays simply because of the fact that the hardware power can kind of hide that. It can basically, you may not know that somebody has written a poor program simply because of the power of the hardware. You can
Yep.
still get the similar performance.
Yeah,
So one
that's
of
a
the
good
things
point.
that I try to kind of impress upon people, including my team, including wherever I teach courses, is the fact that there is no real substitute for good programming. At some point of time, if you're doing bad programming, it will hit you, no matter what the power of the hardware is. So,
Yep, that's true.
And I'm hoping that people pay more and more attention to that, right? And it's not hidden behind the power of the hardware.
Well,
No.
also, I think another issue is that the assumptions, underlying assumptions made when doing the programming. For example, my son and I were talking about the correlation between ice cream sales and shark bites off the eastern coast. So, like, just because there's a pattern does not mean it's necessarily causal.
No, but you know what the answer to that is, Susan. There's a
No.
correlation because the sharks were eating that ice cream. It irritated their teeth and they bit more.
Or somebody doesn't want to share.
That's right.
Yeah, no, there are many examples of that, in fact, Susan, out there. In fact, if you search internet, you will find many of these examples of what I call as typically spurious correlations, right? They are correlations by luck, right? Or sometimes manipulated data as well.
Yes.
Right? They don't necessarily mean any causation or any real relationship.
Well, that comes down to like statistics. If you look at statistics, they can be made to do anything you want, or they
That
can be
is-
interpreted. I love when I watch commercials saying, this person is now 1,000% better than he was before. Yeah, but 1,000% of what? 1 penny? It's like, if you look at what the numbers are, then all of a sudden you realize that people are constantly misleading. Now, that's interesting because you were talking about the data integrity. I could see where if you have control over how the data points are mapped or identified, that would be easier to achieve. How do you deal with situations where you don't create the data? You have to instead analyze it, not necessarily knowing how they programmed it. How do you work around situations like that? That could definitely be a risk or a place where data integrity could be at risk.
No, that is true. In fact, yep. I mean, very correctly said that there, if you don't have the background information, or if the person providing the data or the company providing
Okay.
the data don't have the background information, it gets quite difficult, especially if you don't have the knowledge in that domain.
Yeah.
I think if you have sufficient knowledge in that domain, you can certainly apply that knowledge along with a bunch, lots of tools and techniques today in order to improve the quality of the data. In fact, this is one of the things we try to do at our company, where we kind of use our domain knowledge in oil and gas and in healthcare along with the data science. Right? We typically tend not to do, let's say, a pure data science initiative where we don't know anything about the domain. Right? And that helps actually. That helps in both recognizing that if there is a data quality issue and making some efforts to improve that quality. Right? Without that domain knowledge background, I think it will be very difficult to in fact recognize those issues. Forget about correcting those issues or taking any steps to mitigate those issues. It will just be very difficult to just recognize the issues in the first place.
That makes sense. So you verify the
Definitely,
data.
the domain knowledge is very good.
So there's kind of an
I would say
audit to verify the. So there's an audit to verify the processes of how the data is created, and then you also go in and verify that process, and then again determine how that data is to be analyzed. Is that correct?
Both, well, I would say partially an audit to understand how the data was generated, because
Yeah.
sometimes you may not know actually, can't
Okay.
get that information. But looking at the various pieces of the data, right, that we can connect together. And sometimes, it may need information from other sources, right? We may have auxiliary information from other sources which we can connect together, and we try to make sense out of it. So,
Okay.
a lot of the, I would say, knowledge about whether the data is correct or not is sometimes hidden in the data, right?
Got it. Yep.
So you can look at surrounding data, you can look at other data, neighboring data, in order to correct sometimes the poor quality data.
Now, sometimes would you say, and this is an old saying, that usually things are hidden in plain sight? Do you find cases where you're looking at data and all of a sudden it's so apparent and nobody saw it before?
Oh, definitely. This
Yeah.
happens, in fact, all the time, right? Where you may not have paid special attention to that aspect of it because you are either too deep into something, right? In fact, what I found is sometimes just a fresh pair of eyes looking at it,
Yes.
or taking a break and looking at
Yeah.
it next day, and sometimes you discover insights like that.
Yep. I remember when I did a lot of programming, you would always, if you had a problem, you would always say, can you take a look at this? And somebody else would look and go, oh, here's your problem right there. You spend 8 hours and you're not seeing it, and like you said, fresh eyes, they walk up right there. They can see it immediately. They're not as close to the code. And that's always been a fascinating, it's amazing how in that team kind of environment, one can help another very, very quickly. Now, as a programmer, as a software engineer, how do the components of machine learning learn? In other words, how do you train the machine or the analyzer? Are they learning how to analyze better, or are they learning how to perform the job of data gathering better?
I would say both.
Both, okay.
And the reason I say that is initial goal, of course, is to make sure that they learn how to analyze the data better. But if you cannot automate the generation of the data or the acquisition of the data, then it becomes too big a venture basically to do the analytics. Right? If you can't even get hold of the data or get hold of the data in a timely manner, you just can't do the analytics because you just don't have the data. Right? So
that makes sense.
From that aspect, we try to automate the acquisition of the data end to end, right? Because that's a kind of generally a mundane task. If not done, then you can't really do an advanced package.
Okay.
Right? So you're trying to generally automate the acquisition of the data using the machine power. And then the next step generally is that how to teach the machine first to analyze the data, and second, once it is able to analyze the data and let's say able to make predictions, at some point of time allow it to make the decisions. Right. So based on what it found with the data, let's say take a self-driving car example again, right? Let's say machine discovered an accident is about to happen, right? The next step that has to be taken is what should it do? Should it brake? Should it turn around? Should it honk to distract the person? And how fast it should make the decision? And should it make the decision itself? Right? Being able finding out the action to take and then being able to take that action. Right? That is the ultimate goal of the AI. That is where the automation and real machine learning, I would say, comes in, where you teach the machine to the extent that it is not only able to make the decisions itself, but is also able to do the feedback loop by learning from those actions and improving itself over a period of time. Of course, that does not happen in the first step. Right? First step is typically a human being looking at the data, trying to figure out what the data is showing, and then trying to teach the machine just to make some predictions. Right? Rest, all of it, which is ability to take the action and all, comes after that.
But this is where I think that there's a possibility for incredibly evil sabotage. Because because you think about it, you're at the point where you're needing to train the model. Okay, so if you have people, and again, this is kind of tying back to what you're saying about needing to have domain experts. If you don't have domain experts, people can come in and train the model to actually seek out dangerous situations, like in the case of self-driving cars. Or you could train the model to, if somebody's wearing sort of a red shirt, to take them out. Or, I mean, you could have it do all kinds of. Training the model becomes really critical.
That is true, Susan. In fact, that is why, in general, I would say most successful data science initiatives, they always have some domain experts in the team as an integral part of it. Right? If they don't have that, in general, I see that as a recipe for failure for a data science person.
And the model
you
needs
know,
and the model needs to be focused on theory, not just pattern recognition. I mean, that's where, yeah, because a lot of people think, okay, well, it's just a matter of patterns, and pattern is knowledge, knowledge is patterns, meaning comes from patterns, kind of, but without any fundamental foundations of theory, it's really going to be problematic. And we see that a lot with geophysics and geology.
no, that is true. In fact, without the help of a domain expert, I would say it's very difficult to identify the opportunity itself for data analytics, right? To identify the opportunity and the problem, you really need somebody who is well versed in the domain to say, yes, this is an opportunity, this is the kind of value it will bring in, right? And the second thing is, once you have come up with a solution, how do you vet that solution and say it really works, right? Not necessarily just a spurious correlation, but it really works and it supports the science, right? And to do that, again, you need a domain expert. There has to be somebody who can actually do the validation and bless it and say, yes, we have enough confidence to put it into action. And especially more so, if there is risk to human life involved, definitely people would not deploy that. If there isn't a domain expert saying, yes, this is the point of time at which, yes, I can leave it to the machine. And again, I keep on repeating that self-driving car example, but that's a great example, right? There's a great risk to human life. We have already seen accidents with self-driving cars. And that is why the industry is approaching that problem very carefully, right? They're going very slow simply because they want to make sure that there is no chance for failure there. You want to be 100% correct.
No.
Right? And statistics generally is not a game of 100%, right? It's always a game of 75%, 90%, 95%. Statistics is never 100%. So where human life is involved, you have to be very, very close to 100%. That is why those initiatives they have a large amount of attention. They are garnering a lot of attention where these kind of things are involved. Of course, if you compare to the real world, again, compared to a self-driving car, when humans are driving cars or any other vehicle, we still have accidents today.
For sure.
So the goal is really to minimize those at the end of the day.
And the biggest problem with the self-driving car issue that we've run into is the self-driving car knows what it's doing, but the drunk driver or whoever else is coming at it is totally unpredictable. There's too many possible permutations of what stupidity they could do in that car, and it's hard to predict that. That's, it's not. I think the problem hasn't been the self-driving car. It's the other cars, no matter what they're doing, because it's hard to predict a million possible outcomes. And they do pretty well considering, but it's still, that's until I think they can get that corrected. Now, they're talking about having something like what they do for airplanes, where, for example, airplanes landing at, some airplanes are not allowed to land at certain airports because they don't have the proximity systems in place to let them know where other airplanes are in their 3D space. So if you don't have that, then they won't let you go into a big airport like LAX or Houston or anything like that, because too much risk. But if you have that equipment, it will tell you through the transponders where everybody is, and they have almost no accidents with those systems in place. They really work well. But again, they've controlled that because every car is, or every airplane is equipped with the same kind of equipment to be able to handle that, which we haven't gotten to in the cars. Imagine the day where all cars can have some chips to, or sensors to tell where, to talk to each other, at least at one point. Then you have augmented reality where you have the person's driving, but there's another part of that car that is communicating all around it. That would be fascinating. Let's see where that goes. So.
Yeah, no, definitely. I think it's a managed ecosystem approach. You need a managed system ultimately at the end of the day. And one thing that excites me about that particular aspect of it is, if they can all communicate, I think that's one of the great ways to solve the traffic problem. Because without a fully managed system, I don't really see a solution to the traffic problem.
No.
I mean, majority of people use some kind of today, some kind of navigation device, Google Maps running or something else running, but till a very, very large percentage of those people, right, use exactly the same app generating the data, which is being managed in a central location. They don't see that kind of traffic problem getting solved.
Right.
And that, I think, is a good way basically to solve some of these large problems which impact a large percentage of the population today.
Yep, that's true. Susan, do you want to wrap up?
Well, great. Well, okay, Sunil, at the end of the day, at the end of the interview, we have our classic question. So, what is it in your life that has given you an edge?
So I would say, I've worked in the oil and gas industry for quite some time, right? So that experience definitely has been invaluable, right? In addition to that, I would say the support of the family, right? So that is primary, I would say, in making any decisions in life, as well as the upbringing. The upbringing that I went through in India, the kind of support we got from the parents, and the kind of education we got. I think that has made a big difference in terms of how I have lived my life and how I continue to kind of, you can say, grow and evolve. Right? So, and that is why some of these initiatives are very close to my heart. Anywhere where I see an opportunity to improve the education standards, right? Anywhere where I see an opportunity to improve, especially the primary education, which is to get the primary education to more and more people, right? I always support those initiatives because of that reason. Because I think education brings a great transformation in the community.
Well,
that's wonderful.
Yeah,
I agree.
It is. And we hope you continue having that support from your family and everyone else, and you live a long life. We need people like you. So
thank you.
Appreciate it.
Well, thank you. This is fantastic. It's such an interesting interview. Really appreciate you being on the show, Sunil.
Yeah, we'd love to have you back on again, maybe in a year, and show us more of how it's evolving, because you're in an industry that is truly evolving. It's very fascinating and interesting seeing how that grows and where it's going to take you, because I'm sure you're going to go places that you didn't even think about up front.
No, that is true. In fact, I also think so. Like I mentioned earlier, a lot of what you see in the analyst literature, it says we have reached the peak of machine learning and data analytics. I really don't think that we have reached the peak, neither in the oil and gas industry nor in other industries. I still think the best things are yet to come. Yep. And I think this field AI will play a great, I would say it will be a great impact in general on the lives of the people, right? In general, in improving the quality of lives of the people.
That's great.
So, I look forward to that exciting.
That'll be fun.
Yeah.
Well, we look forward to sharing that with
Susan
you.
and Rick for having me here. Yeah.
I'm sorry?
Thanks a lot for having me here.
Our pleasure. Thank you for coming. And
thank you.
And if you're watching the show in either the chat room or watching the recording, please subscribe. Underneath, we will have information on how to get in touch with Sunil, find out more about his company, and if you have a need, I'm sure he can probably help you. And we will see you next week. Susan, till next time. And for all of you, if we don't see you then, have wonderful holidays, and we will see you next time. Have a good one, everyone. Thanks. Bye-bye.
Thank you.
Thank you.